Part of 7.4, we're going to look at partial fractions, which in a way relates a little bit to what we did with rational equations. So with partial fractions, what happens is I'm giving you the answer, but I'm not giving you at all the other side of the equation. So let me scroll up. If I take a look at this up here, the problem we did is I gave you both sides of the equation, the left side and the right side. Now, what's happening is you are going to create this right side from the original. So we have this. The way to go about it is to first factor. Take a look at the denominator, and we have x squared plus 5x minus 24, and I am going to factor that. So let me set that up. I have x squared, and I'll put in the top left. The negative 24, I'll put over here. So what adds to 5x but multiplies to negative 24x squared, and that would be a positive 8x and a negative 3x. So the factors, let's see, the top has an x in common for a GCF, so x and x is x squared, x and negative 3, and then I think positive 8 here. So the factors are x plus 8 for the denominator and x minus 3. Now let's follow, like I said, some of the similar steps to what we did with rational equations is let's find the excluded values to that. So the excluded values are going to be x cannot be negative 8 and x cannot be 3. It's very similar to kind of the idea behind common denominator that we dealt with in excluded values from rational equations. Now what happens is we have to realize we only know one side of the equation. So if I kind of write down, I'll put it here, what we know. I know the final answer is 9x minus 5 over x, and I'm going to write it factored, x plus 8, x minus 3. I know that. I just have no idea what goes on the other side. So I'm going to create the other side. I'm going to make one of the fractions have the x plus 8. And I'm going to make the other fraction have the x minus 3. Because that would give me a common denominator of this, so I'm going to create it that way. So we use our factors to create the two fractions. But we have no idea what goes on the top. So we use a capital A and a capital B for what goes on top. And that's what we're going to solve, is we're going to find the values of A and find the values of B. Now, when I talked about this in class, I tried to really emphasize that this right here is the most important step because it tells you what your final answer is going to look like. And I'm so confident about that step is extremely important. I am going to put an arrow and just go right down here to show you that somehow that is going to play a role in our final step. And I have no idea what that final step is going to be yet, but I know this is going to play a role in it. So to go, the next idea is just the same thing we did up here. We are going to create the common denominator and think about it like solving. So we already know the common denominator. I already know that it's going to be x plus 8, x minus 3. So if I look at this first fraction on it, it appears, and I'm going to show all the steps at first, and then I'm going to kind of limit it to make it a little bit easier, is the first fraction, a over x plus 8, and I'll put that in parentheses, it's missing this x minus 3. And so I'm going to multiply the top and bottom by x minus 3. Now it has that denominator and I'm good. So let's look at the next one. Plus b over x minus 3. Well, that's missing the x plus 8. So I'm going to put that in the bottom. And to keep it balanced, I'm going to put it in the top. And now that one also has the common denominator. And it should equal my 9x minus 5 over the x plus 8 and the x minus 3. So we're kind of following the same steps we did for a rational equation. We're creating it, and we are going to next realize we can cross it out. We don't need it. They all have the same denominator now, so we're not even going to bother to look at that. So I have a times x minus 3, and I'm not going to distribute. B times x plus 8 equals 9x minus 5. Like I said, I'm going to show all the steps at that point. I'm going to show you right now a little shortcut for it, because I have the ability to skip this entire step right here to make it a little bit easier. So I have the ability to go from this part right here to this part right here. The idea is what's missing is this has the x plus 8, but the a, it's missing this x minus 3. So I'm going to put that x minus 3 up to the top. This b has the x minus 3, but it's missing the x plus 8. So I'm going to bring that up to the top. If you look at my completed notes online on the portal, you would see, and I'm reluctant to use the phrase, but it is a visual pattern that's kind of like cross multiplication on it. But the important part is to still show that step. So I could cross multiply, because you see I have the a times x minus 3. I have the b times x plus 8, and it equals this 9x minus 5. And then I don't even have to worry about the fractions anymore. I can go right to this work. So there is a way to skip this process, this middle step right here completely. Now the question is, well, what do we do from here? And it's a good question, because we have 3 variables. We have an a, we have a b, and we have an x. And it's a little confusing with so many, but you need to realize we have some values of x we have not used yet. We have not used these excluded values. So I am going to plug in my excluded values. So I'm going to plug in -8 for x. So I have a times -8 minus 3 plus b times -8 plus 8 equals 9 times -8 minus 5. Well, this gives me -11a right here. That's not bad. But what happens here? I get -8 plus 8, which is 0. And 0 times anything is 0. So it goes away. So I'm only left with -11a. I'm only left with one variable now. Let's look at the right side. I get -72 minus 5, -77. A, if I divide, is +7. We have the value of a. So by plugging in one of the excluded values, it cancels out one of the variables. In this case, it was b. We plugged in to x, and I was only left with the variable a. I wonder what happens when we plug in the other excluded value, which in this case was +3. So same idea. I have a 3 minus 3 plus b times 3 plus 8 equals 9 times 3 minus 5. Let's see, 3 minus 3 is going to be 0. And 0 times anything, well, that just cancels out, just like on the other side. This time it's the other variable. On this side, b cancels out. On this side, a cancels out. And let's see, 3 plus 8 is 11. It's just a coincidence that they're both 11. 9 times 3 is 27. Minus 5 is 22. So b is 2. Well, now I have a, now I have b. That's perfect. That's what we're looking for. So I'm good. But the problem is that's not my answer. I did say this is the most important step. And let me get rid of some of this purple marking here to make it a little bit easier to see. That right there is the most important step, because we saw visually we have this cross multiplication pattern that allows us to set up this right here. And our excluded values is the next important step, because that allows us to solve. But I did, and I'm off a little bit with my arrow, so I'll extend it. I did say I'm going to come back and I'm going to use this. because my answer wants the fractions. And I have a over x plus 8 plus b over x minus 3. Those are the things I'm looking for, and I was looking for the values of a and b. So rather than writing down a, I'm going to write down 7. Rather than writing down b, I'm going to write down 2. That is the answer. And the order that you put, let's say the order, the place you put the number, 7 has to be on top of x plus 8. The 2 has to be on top of x minus 3. If I would have factored differently, if I would have written my factors like x minus 3 times x plus 8 and then written the fractions separately, I would have gotten an answer that looked like this: 2 over x minus 3 plus 7 over x plus 8, which is the exact same thing. They're just in the opposite orders for it. So we can solve, we go through the process, we get it, it's done. And how do I know if I'm right? Or what if I make a mistake and I put my a over the wrong number? And it's actually quite simple. That was a 2. And so what we can do is go back to the idea of cross multiply. How do I check my answer? Cross multiply. 7x minus 21, 2x plus 16. If I combine those, I get 9x minus 5. And if I go back to the original problem, 9x minus 5, I know 100% I am right. There's no mistakes on this. And I say this step because what if you put the wrong number over the wrong variable expression? So what if I accidentally put the 2 over the x plus 8 and the 7 over the x minus 3? Well, if I cross multiply here, I get 2x minus 6. I get 7x plus 56. I do get the 9x, which is awesome. But I get a plus 50, which is not what I was looking for. I wanted the minus 5 in the original. So if you ever check your answer and you cross multiply and you see this constant does not match, what that means is just take your numbers on the top. Don't redo the entire problem. Just take those numbers on the top and switch them. That's all you need to do if you don't get to work. But I strongly encourage you to cross multiply and check your answers on it. It'll allow you to make sure 100% you are correct with the process. So we'll take a look at this one. I'm going to use a shortcut right away to just kind of show you how fast it can be. I'm going to factor. The denominator, kind of think of it just like common denominator, is the x squared goes here, the minus 3 goes here, and I want them to add to 2x. So what multiplies the negative 3x squared as the positive 2x? I'm going to say 3x and negative 1x. So for my factors, the top row has x GCF, x times x is x squared, x times negative 1, and a positive 3. So my factors, which is kind of like your common denominator, are x plus 3. Again, the order doesn't matter. X minus 1. My excluded values are x cannot be negative 3 or 1. And now we can set up our fraction. We know we want it to equal 2x minus 6 over x, and I'm going to leave it in factored form, x plus 3x minus 1. But I don't know the left side, so I'm going to create my left side, and I'm going to use my factors to help me. I'm going to use the x plus 3 as one fraction, and I'm going to use the x minus 1 as the other fraction. And order doesn't matter. And because it's me, I like to put them in parentheses just so I see them as an object. I'm going to put a capital A on top of that one, a capital B on top of that one, and that is it. That is the key number 1 for finding your answer, key number 2 for finding your answer. And we're going to think of it, like we said, like cross multiplication. I said I'm going to use the shortcut in this way. This fraction, a over x plus 3, it's missing the x minus 1. And so what I'm going to do is I'm going to think about it like cross multiplying. I'm going to take a times that x minus 1. I'm going to take b times the x plus 3. And that's going to give me my 2x minus 6. I skipped this entire step completely compared to the previous problem. So this is the first key to solving. And I said the second key to solving is right here. is your excluded values, x, and I'm going to plug them in, -3. So a times -3 minus 1 plus b times -3 plus 3 equals 2 times -3 minus 6. And notice the first one gives me, looks like a -4a. -3 plus 3 is 0 again. I mean, look at that. 0 times b is 0. It goes away. So it seems like that's always going to happen. And 2 times -3 minus 6 is -12. So a is 3. I know the value of a. Awesome. Now I can plug in the other excluded value, and I should, if things work out right, get the value of b. So x equals 1 was the other excluded value. So a times 1 minus 1 plus b times 1 plus 3 equals 2 times 1 minus 6. Let's see, 1 minus 1 is 0. 0 times anything. Look at that. The other one cancels. And I get b times 1 plus 3, so that'd be 4b. 2 times 1 minus 6 is -4, so b is -1. And so now I know the value of b. And I use, still, this is the key, right up here. A, I'm going to write it, and then I'll erase. A is over x plus 3. We said b is over x minus 1. But I know the value of a. A is 3. So it's 3 over x plus 3. I know the value of b. B is -1, so it's -1 over x minus 1. So I have to write this step down because it tells me where to put my a value and where to put my b value. And if I want to check my answer, I'm just going to cross multiply. I get, looks like 3x minus 3, and I get -1x minus 3. That gives me 2x minus 6. Look at that. That was exactly what we asked to find. So I know I am 100% right. I can box that answer and say that I am set and go from there. So I hope you understand. Hopefully these two examples kind of clarify partial fractions. You can do the on your own ones or the next couple problems on the back side to help you out further. But overall, there are the most important steps are the setting up this fraction, the two highlighted parts in your excluded values. Notice how we always went back to either one of those. When we started the problem by setting up with the cross multiplication, when we solved for our a and our b values, and then it even told us how to write our answer at the end. Those are the two most important steps. Hopefully this answers some questions with partial fractions.